Hello, today we are going to talk about the real number system. We have talked about the number system before. We have classified numbers such as whole numbers, integers, rational. We've also mentioned irrational numbers. Remember pi. Irrational numbers are numbers that cannot be written as a fraction. We are going to compare real numbers, put them in order, and solve equations using real numbers. Most of these numbers we've been working with before, but we just want to have an idea of, how all of the numbers fit in together. So let's go ahead and just remind you guys what rational numbers are. Remember to be quite rational, my dear Watson. So rational numbers, usually we use a Q to describe rational numbers, and they are numbers that can be written as fractions. This includes almost every number we have ever worked with. So 7/9, -1.1, that could be turned into a mixed number and then a single fraction. 0, 2. Repeating decimals, remember we have a process that changes repeating decimals into fractions. If you don't remember that quick trick of just saying, oh, well, this is 3 out of 9, 3/9 or 1/3, you can say n equals 0.3 repeating, and you multiply it by 10 to move the decimal over one place, and so on and so forth, and then we end up getting, a fraction. So we convert repeating decimals into fractions. So any repeating decimal can be written as a fraction, even if you are a little unsure of what that fraction might be. Here, 2 digits repeating, we would get 27/99, and then you could reduce it from there. So rational numbers, most of the numbers we work with. Irrational numbers are numbers that cannot be written as a fraction, and they don't include a whole lot of numbers that you will be working with now. So irrational numbers are the opposite, numbers that cannot be written as a fraction. One of the most famous you've been working with recently, pi. Okay, there's an approximation for pi, 22/7, and that's a fraction, but that is not equivalent to pi. There's no exact fraction. It turns out also, now that we've been working with square roots, the square root of 5 is an irrational number. It's a decimal that goes on and on and on. You can even make up a decimal, 0.042225 ... It has to go on forever and not repeat. Okay, so those are irrational numbers. And when we go back to our visual, we have something like this. These are our whole numbers. We have like 0, 1, 2. Then we have our integers. That's an awful circle. Let me try that again. It doesn't even have to be a circle. It can be some kind of oval. Okay, it's close enough. So we have our integers, and I think we used z before to designate integers. So I think I'm going to use I for irrational, but we'll see. And integers are whole numbers and negative numbers, like 0, 1, and 2, but also -4, -5, things like that. Then, of course, we want to add fractions and decimals into the mix. So that's where our rational numbers come into play, Q. Okay. And then off on the side here we have, it really has to be off on the side, not a part of. We have our irrational numbers. They are totally set aside, set apart. There's pi, square root of 5. Altogether, though, rational and irrational numbers make up the real number system. So these are all real numbers. Later on in higher mathematics courses, you will start to learn about imaginary numbers and how those come into play. But all of these numbers here, even if they're irrational, They're still real numbers. So I just wanted to point that out. So let's go ahead and classify for a moment. And if you need to write out the words, you may. I don't think the book gives you directions. I think they just ask you to write out, whole, integer, rational, or irrational. I'll let you use I for irrational if you'd like. So whole, integer, rational, or irrational. Remember, if a number is irrational, it cannot be a whole number or an integer or a rational number. If it's irrational, that's all it can be. So please just keep that in mind. And I would like you to go ahead and classify the following. So let's say I have 21/7, negative 2.5, 0.2 repeating, and the square root of 38. So you may use a calculator here to get that number. And we'll talk more about that in just a moment. Hit pause and then hit unpause when you're ready to see the solution. Okay, go ahead and compare your solutions to mine. For the first one, it's whole and integer as well as rational. The second one is just rational. The third one is just rational. Remember, it's a repeating decimal, but any repeating decimal can be written as a fraction, so it's rational. And then when you calculate the square root of 38, you see that you get this long decimal that does not appear to repeat, and it goes on forever. When that is the case, you need to label it irrational. So what about square roots? Well, just in general, with square roots, just as a little aside here, unless you have a perfect square, you're probably going to get an irrational number. So most square roots are irrational, and you can see it when you type them into the calculator. Square roots of perfect squares are not. So what am I saying here? Well, if you were to take the square root of 5, go ahead and calculate that. You get 2.2360679. Okay? So when you're looking at this number, even though we don't have the whole thing presented to us, we can see that it's a decimal, it goes on forever, and it does not repeat. So we can see that this is an irrational number. We can still work with it. It's still a number. It just can't be written as a fraction. But if you type in the square root of 16, you get 4. That is obviously a whole number. It's also an integer, and it is rational. So it's not as if every single square root is an irrational number, just some are. If it's a square root of a perfect square, it will be, it will have other classifications. Let's go ahead and compare numbers. Again, you may need to use a calculator to help you figure these things out. So compare, contrast, we're just basically seeing what's bigger, what's smaller, okay, or are they equal? So if I wanted to compare 3 1/3 to the square root of 15, it's always easier to compare numbers when they're of the same format. You want to compare apples to apples. So here, when you calculate the square root of 15, you will get 3.872. 3 1/3, we know 3 1/3. You should know that's 0.3 repeating. If you didn't, you can do 1 divided by 3 just to get the decimal portion, okay? And that will give you the 0.3 repeating. And what does 0.3 repeating mean? It means that it's just 3, 3, 3, 3, 3. It's helpful sometimes to write that out so that you can compare place values. Obviously, I don't have to go too far. The tenths place tells me right away which one is bigger and which one is smaller. So I will go ahead and say that 3 1/3 is less than the square root of 15. Let's go ahead and take a look at some negatives, because again, you just want to be careful with those. So for example, let's say you wanted to compare the negative square root of 30 and negative 5.6. Okay. You'll need to compare items, of course, when you're putting numbers in order from least to greatest or greatest to least as well. So these skills will come in play with other numbers. And this is just developing your number sense. You need to have an idea, what's bigger and what's smaller. That's why we do these types of exercises, and that's why we practice this math. It's just to get an idea of what kind of numbers exist and how we can work with them. So when you calculate the square root of negative 30, it'll be somewhere around negative 6, because I know 36, the square root of 36 is 6. But when I calculate it exactly, I get negative 5.477, and I can stop there because I only have the tenths place here. Now, these are negative values, so remember with negatives, sometimes it's the opposite of what you might think. The larger number is closer to 0, and it turns out that negative 5.4 is closer to 0 than negative 5.6. So I will say that, negative 30 is the negative square root of 30 is greater than negative 5.6. So again, just use these skills when you are putting numbers in order from least to greatest. Let's go ahead and talk about how we can solve equations involving squares and square roots, because we've worked a lot with equations in Chapter 5. So with an equation, you might have something like this, and we'll start off with some basics at first. Okay, let's say you have a squared equals 36. Now, when you solve equations, it's all about working backwards and undoing operations. Well, how do you undo a power? And in particular, the second power? You can take the square root. Okay, that is its inverse operation, to take the square root. And this is how you balance it, and this is what I must see. Okay, so you must show the balancing step, just like you would with anything else. If you were adding or subtracting on each side of the equation, multiplying or dividing, I need to see this balancing step. So what does it look like? Well, let me show you. It looks like this. Okay, so here is my equation. I'm going to take the positive and negative square root of each side of this equation. Okay, so this is the balancing step that must occur on each side. And I can only do this after everything else has been taken care of. So there was no addition or subtraction or multiplication or division to undo. So this is the only step I need to do. But this would be the last step. So why am I taking the positive and negative? Well, you can think about this logically. What number times itself equals 36? I mean, that's the question we're asking ourselves. You can answer this without showing the work, but we need to show the work to justify our solution. 6 times 6 equals 36, so a could equal 6. But there's another root. Remember, each integer has both a positive and a negative root. So I could say that a also equals negative 6. I mean, I don't know. I know that negative 6 times negative 6, though, equals 36. So that's why I have to do that plus minus on each side. This undoes my square. I end up getting a, and then I can take the plus or minus of the square root of 36 and get plus or minus 6, and that would be my solution. Or I could say a equals 6, or a equals negative 6. And again, you can check it by substituting each value back into your equation and proving it true. Let's say you have something a little bit more interesting. Okay, it's a two-stepper. So 2n squared equals 170. So I'd love to take the square root, but first I have something else going on. I have multiplication. So 2 times n squared. And I want to undo that multiplication first. So let's go ahead and undo that multiplication by dividing. That cancels out the 2. I get 1n squared, or just n squared. And then think about it. What's half of 170? Well, 80 and 80 would be 160, so 85 and 85 is 170. So now I'm back to where I was before. I can take the positive or negative square root of each side. I'm going to squeeze that in there. I'll end up with just n because I'm undoing that square. And when I type this into my calculator, I get plus negative 9 point, and let's round to the nearest tenth, 9.2. And again, if you wanted to present your solution this way, that would be fine as well. Okay, I think we'll save the rest for class, and we'll work with these in class. So hold on to your questions, and I will see you then. Thank you. Bye.